On the module 14 and 15 tests, half your grade is going to come from over here, chapter 15, section 4, and I already told you this. So I'm going to send you a link to this practice questions right here. So I want you to go ahead and work on it, and I'm also going to give you the answers. And so that way you can actually go ahead and compare your answer, okay? So today I'm just gonna show you how to do just a few questions so you'll be prepared. I'm not giving you all the questions, all the similar questions that's gonna show up on the test. However, if you study and do all the things that I ask you to, you'll be guaranteed an A, okay? So let's take a look. The first thing that I want to work with you on is this question here. A car with an initial value of $23,000 is decreasing in value at a rate of, let me just go ahead and change this a little bit though. Okay, so it's not working. Never mind then. So a car with an initial value of $23,000 is decreasing. So we know we have to subtract what? 8%. So we know 8% is what? 0.08. Okay. Of course, why do you think I'm doing this? Because we're going to have one problem that looks like this, okay? 0.08, and it's decreasing, so we have to do what? Yes, we have to subtract from 1, and that's going to be our rate. The initial value is 23,000, and at this rate, approximately what will be the value of the car in 3 years? So, on the test, most likely I would tell you to set up an equation, okay? Because you have to. And then most likely then I would tell you give answer. And of course, this is a multiple choice question, so you just have to select the correct equation. And so I already gave you the generic formula. F of n is equal to a times b raised to the n power. And we already talked about how a is the original or initial value, and then b is the rate. And then n is obviously the time, or whatever, right? So let's take a look. Original value is 23,000, so f of n is equal to 23,000 times the rate. And we already talked about the rate here. It's decreasing, so we're subtracting from 1. 8% is 0.08, so it's 0.92 raised to the power of n. So that would be the equation. That was so easy, right? And then you have to give the answer. Well, how would you give the answer? At this rate, approximately what will the value of the car be in 3 years? So all you have to do is plug in 3. So on the 0th year, when you just purchased the car, right? The car is worth $23,000, but after 1 year, now the car value is dropping. You know that cars don't get more and more expensive unless it's like one of those really, really awesome cars, like oh gosh, I don't know my cars, but anyhow, you know what I mean. So anyway, this car, after a year, is going to be worth how much? 23,000 times 0.92. So after 3 years, how much is it going to be? We just have to plug in a 3 over there. So you know what? I'm just going to put, for question number 2, let me just change the color of my pen. I'm just going to put f of n equals 23,000 times 0.92 raised to the 3rd power. I could very easily tell you to draw a graph for me on this one, but I won't do that because you have to do graphs and all that stuff for that one open-ended question, and that's gonna be intense. So for you to solve this, what do you have to do? You just have to plug it into your Desmos. And of course, you can use it on the day of the test. That's the whole purpose of me showing you how to use it, right? So I go into my Desmos calculator and I go 23,000, and then I open up my parentheses and put 0.92 raised to the power of, now I'm going to put 3. And so, of course, it will give me the answer right away. And there you go. I just kind of highlighted and copied the answer, because what I want to do is I want to just go ahead and paste it here. So the answer is, there you go. But then, hey, are you really going to say that this is the answer? No, because first of all, what are we talking about? We're talking about the initial value. So I'm going to try and trick you on the test. I'm going to go ahead and I'm going to say option A is this. in dollars, right? Because I want to know if you have common sense. Do you say that a car is worth $17,909.82.4? I don't think so, right? And then maybe I'll give you another option that says it's $17,909.82. That kind of makes sense, right? And then, of course, another option would be some horribly wrong answer. But anyhow, my point is that in 3 years, the car will be worth not this, but that. Okay, so your correct answer is this one right here. Okay. All right, so make sure you keep that in mind. Make sure you know how to set up an equation. So this is one of the questions that will show up on the test, very similar to this one, okay? And then now let me give you an example of another question that's most likely going to show up, okay? So there you go. Very simple. It's just gonna tell you to solve something like what is 1 over 4 times 8 raised to the x power, okay? Let me just check something really fast. All right. Hi. For some reason, I thought that I was not recording and then I panicked. I thought I was talking by myself in my room. Okay, so if you were to solve something like this, you gotta find out what x is equal to, right? This is very basic stuff. You're supposed to know how to do this if you went to middle school, but in high school, most of the things that we do, we use the calculator because, it's just calculations and calculators can do that for us. We have to do the thinking, right? And calculators cannot think, they could only calculate. Anyhow, I don't want to go off on that one because we have a purpose and we have to review for the test. So anyhow, the first thing that I have to do, the question would look something like solve. Okay. And then so I have to leave the exponent by itself, but you know that the exponent cannot be by itself, so I have to leave it together with the base, which is 8. Okay? So now let's go ahead and get rid of the 1 over 4 because I want to leave the 8 raised to the x power by itself. So I'm going to copy the 1 over 4, but what do you have to do to get rid of the 1 over 4? Well, the relationship between 1 over 4 and this big thing here is multiplication, so I gotta divide. So I'm going to go ahead and divide the 1 over 4, okay? And then you know what I'm gonna do now? I'm just gonna go ahead and copy what's inside my blue box, because that is what I want by itself in the end, right? And then that's going to equal 128. But hey, what did we just do over here? We divided both sides by, let me change the color. We divided both sides by 1 over 4 because we wanted to get rid of this 1 over 4 here. The equal sign tells me that if I did one thing to this side, I gotta do the same thing to the other side. So then people are confused now. Miss Choi, how do you divide by 1 over 4? Well, all we have to do is change the division into multiplication and then you flip it. That means find the reciprocal. Find the reciprocal, which means flip it. So 1 over 4 becomes 4 over 1, which is just 4. So it's kind of like 1 over, okay, so I'm just going to change that on both sides because that's the thing that we have to do. And so there you go. 1 over 4 times 4 equals 128 times 4. And of course, let's not forget to copy down 8 raised to the x power. I'm just color coding for you so it's easy for you to understand, okay? So if you multiply these together, you multiply the whole number to the top. 4 divided by 4 is 1. So you're left with 8 raised to the x power. And then what is 128 times 4? Let me just go ahead and do that really quick. That's 512. Okay, so now what we have to do is figure out how many times do I have to multiply 8 to get 512. So let's see this. 8 times 8 is 64. I'm getting, let me see. 64 times 8 is 512. Oh, so look, 8 raised to the x power is equal to what? 8 raised to the third power. Obviously, we're saying that these two are equal to each other. Since 8 and 8 are the same, what do you think x should equal? You're absolutely right. So what's your answer? X is equal to 3. This is a very easy question if you understand the process. So just please make sure that you try your best to get this done. Okay? All right. So I already gave you 2 questions. And now what I want to do is work on this worksheet with you because this is kind of important. Okay, so now there you go. We're practicing problem solving over here. This is the worksheet I told you I'm going to give you, and I want you to work on it. So it says, without graphing, because there's a lot of questions on this section, right? Without graphing, tell whether each quantity is changing at a constant amount or at a constant percent or nothing, all right? So you have to read the question. Bank account started with $1,000 and it earned $10 interest per month for 2 years. And then the bank paid 2% interest on the account for the next 2 years. So what is this? Let's think about that, right? So in the beginning, the bank is just giving you $10 extra. So it's kind of like adding 10 every single time. That would be a linear function, right? So then the quantity is changing at a constant amount. But that is for the first 2 years. But then after that, they're going to pay 2% interest. That means you have to multiply by 1.02 to the balance every single time. So then now, this time it's going to be a constant percent. So then, for question number 1, your answer would be neither because they have, well, or maybe both. Because they have both the constant and the other one. What about this one? It says Jean Lu earns a bonus for each sale she makes. She earns $100 for the first sale, $150 for the second sale, $200 for the third sale, and so on. So is this changing at a constant rate or at a constant percent? Do you have to multiply by the same number every single time, or are you adding by the same number every single time, right? So think about that one. Question number 3. So this is the one that I wanted to work on because this is pretty much your test item. Remember I told you there's going to be one open-ended question where you have to graph and everything. So let's see. A bank offers, you know what, I'm just gonna give you the answer here. We're adding by 50 every single time, so this is going to be a constant difference, okay? And what that means is if you were to graph it, it's going to just look like a straight line, okay? And so now, let's go ahead and take a look from question number 3 all the way through 8. A bank offers annual rates of 6% simple interest or 5% compound interest on its savings account. And let's suppose you have $10,000 to invest. Express f of x, the value of your deposit after x years in the simple interest account, and g of x, the value of your deposit after x years in the compound interest account. So then in order for you to solve this, you have to understand the difference between a simple interest and a compound interest, okay? So a simple interest means the bank is just going to give you 6% of what you have, okay? 6% of 10,000. Compound interest is a little bit different. Okay, so what I want you to do over here is just have that understanding, simple interest. So you see you have $10,000. So, okay, let's take a look at number 3. Express f of x, the value of your deposit after x years in the simple interest account, and g of x, the value of your deposit after x years in the compound interest account. Okay, so basically they're telling you to give an equation, okay? And in order for you to give an equation, it would be really helpful if you can first graph it, okay? So I would just do that. Here is f of x for me, okay? And f of x is in the simple interest, and here's g of x. And g of x is the value of your deposit after x years in the compound interest account. So we talked about this. Simple interest means you're going to start off with how much? Well, they had $10,000, so we're going to start off with $10,000, right? So I'm going to put 10,000 here, and then I'm going to put 10,000 here. And so when was that? That's when time is 0. That's the amount of money that we had in the beginning. But after, how much time is it? 1 year, 1 month? Annual rate, so that's after 1 year. So after 1 year, they're going to give you only 6%. For the simple interest, they're just going to give you 6% of 10,000. 6% is 0.06. If you multiply that by 10,000, you just have to go backwards in decimals by 2. So 100 times 6 is 600. So basically, they're just going to give you $600 extra. Same thing, $600 extra. 600 plus 600, right? So third year, if they're going to give you another 600. The fourth year, they're going to give you another 600. There you go. And then of course you keep going on and on and on, but we don't want to go that far, right? So for the compound interest though, what that means is you start with a $10,000 balance, and then they're going to give you compound interest. What that means is they're going to give you a 5% increase on your balance, okay? So basically, if you start with $10,000, you're going to multiply that by, remember, 5% is 0.05, but because it's an increase, you're going to add 1. So you're going to multiply by 1.05. I'm going to go ahead and erase this because I don't like it when there's too much writing on the screen, okay? So what we're going to do is we're going to go 10,000 times 1.05. And so we know we don't have to worry about all of that. So it's kind of like 1 times 1.05. So that's 105 with all the zeros in the back. 1, 2, 3, 4. 1, 2, 3, 4. But because we have 2 decimals, we start from here and go 1, 2. So these go away. So how much money do we have? $10,500. So in the beginning, after the first year, it looks like you can make more money over here with the simple interest than over here with the compound interest, right? But let's see what happens in year 2. Because in year 2, what they're going to do is we're going to multiply the 105,000, the 10,500 by another 1.05. Okay? And so, of course, it would be so much better if I could just use the calculator, right? So I will do that. Let's go into Desmos. Go to Desmos, and this is the previous screen. So 10500 times 1.05, and that gives me 11025. Let's go back. 110. Oh gosh, I'm such a scatterbrain. 11025. And then of course on the third year, what do you have to do? You're going to have to multiply 11025 by 1.05 again. Okay? And so again, let's go back to the calculator because I love the calculator. Of course you can actually do this by hand, but it would just take longer. There you go. So now the answer for that is $11,576.25. Okay, so let's go back. There you go. We got 11,11576.25 cents. I'm gonna put that down here because I'm running out of space. Now I know that you probably want me to do one more so we can compare it over here. But at the third year, with the simple interest, you can make 11,800, and in the third year over here, there's only $11,576. So up until this point, if you're only going to invest for 3 years, which one sounds like a better idea? Of course, the simple interest, okay, not the compound interest. just to make it clear, I'm going to put compound over here, and then I'm going to put simple over here, so you know what I'm talking about. Okay, so then, by accident, because we had to create our table in order to get the equation for number 3, by accident, we actually answered question number 5. It says, find the values of your deposit after 3 years. After 3 years, which account is the better choice? And so the answer for number 5 is what? Of course, the choice for simple is better, because in the 3rd year, you would have made 11,000. Your balance would be 11,800 versus if you went with this bank with the compound interest, is your money would have grown to only $11,576.25. Okay, so we already answered this one. Now, as we are trying to solve number 3, we also answered number 4, but we'll do this a little bit later. So what we're trying to do to come up with the equation is we're going to use the line of regression. Okay, so let's go back to Desmos. And now what we're gonna do is we're going to go ahead and insert the tables. Okay, and so again, we started with 0. And I don't think we even have values for that. So at 0, we had 10,000. And then the first year we had 10,600, and then 10,000 and 1,200, and then 1,1,800, right? So this is when we are adding $600 every single time, the simple interest, right? And now I'm going to add another table, of course, because I want to compare it with the compound interest. And so again, we had to start with 0. And where am I getting all these numbers from, guys? We just created the table over here, right? So the first time you have $10,000, but after the first year, you have 10,000 and then 105, right? And then the second time you had, oh, I can't remember that number, but then the 3rd year it was $11,576.25. So let me just go back to get the second number right there. There you go. Oh, it was 5%, so it's 10500. Okay, what's wrong with me? Okay, and over here is 11025. 11025. Let me fix that. 10500. Okay. So then obviously we talked about this. I plotted stuff and I can't see anything. That means there's something wrong. We have to change the viewing window, right? So look at my x values. The smallest number is at 0, biggest one is at 3. But of course I want to make it smaller than 0 and bigger than 3, right? If you go back to the question, it's asking you stuff like find the values after 20 years. So you know what? I'm just gonna make it bigger and put it at like 23. So for axis, I'm going to start with -10 and go all the way to 25. Okay. And then for the y values, I'm just gonna start with -10 because I always just want to see the the line down here. And then the y value, the biggest number that I see right now is 11,800, but I'm pretty sure it's going to get way bigger than that. So I'm just going to put 15,000. Okay, 15,000. So I just want you to see what my rationale is when I come up with the numbers. And so as you can see, as soon as I did that, all of a sudden now the points are here. And come on, guys, let's be honest. If you didn't know what you were doing, you could say, hey, Miss Choi, it's kind of like 2 straight lines. I could connect the dots for the green ones, and I could also connect the dots for the white one. It's just that the black one is growing at a faster rate. So if I were you, Miss Choi, I would just invest money with the black dots, which is the simple interest. But see, that is why we need to learn math, because math is not about calculating. Calculations can be done by calculators, but Who has the brain? We do, and we have to tell the calculator what it is, okay? We already know that with the black dots we were adding by 600. So we know that the black dots is going to be what? It's going to be a linear function. So we're going to go ahead and give the calculator, you know, the linear function, and we're going to ask it to give us the equation. But then on the blue ones, you and I already know that this is an exponential function because what did we do? We multiplied by 1.05 every single time to get to the next number. So even though these green dots look like a straight line, we are people, and so we have brains, and so we already know that this is going to look like an exponential function. I don't know if it's going to start curving here, or I don't know if it's going to continue going like this and then eventually curve up. I really don't know because, again, that's something that we have to calculate, and it would just take me a long time, and that's why we have our handy dandy calculator so they could do it faster than us, right? So you know what? Let's just go ahead and ask the calculator, hey, you see the values over here? X1 and Y1. I know that that's going to be a linear equation, but why don't you tell me? Can you tell me? Oh, I forgot to put 1 here. Can you tell me what kind of equation that is? Oh, and so guess what they did? They just drew a straight line for me. And if I click on the residuals, you will see that there's no difference, which means this is a perfect fit, right? So then I told you to just match it. Y is equal to, and what was the value of M? Calculator told me what? Oh, 600, because we're adding 600 every single time. And 600 times X plus B, and what's B? Oh, 10,000. All right, so then I see that the two graphs match, and so what did I do right now? I just got the equation for the first set, okay? Which is the equation when the customer decides to go with the simple interest, okay? So now let's take a look at the second set of tables. We already know that this is an exponential, right? So you know what? If I ask the calculator to give me the equation and I give them a linear function because I didn't know any better, they're just going to give me a linear function. But guys, we're very smart. We already know what we did over here on the table. We multiplied by 1.05, so we know this is an exponential function. So we're going to ask the calculator, hey, can you give me the equation? I think I know it. I think this is the exponential. Well, not that I think. I know for sure. Sorry, my bad. I need to make sure that I use the second set of numbers. Why am I using the little 2's? Because I'm trying to get these, and it says sub 2's, right? So I'm using sub 2's as well. So then, like I said, what is it doing? All of a sudden, the blue graph showed up, right? And it is showing me a little curve. It's different from the orange one, right? So I told you to match it. And you know what? Right now, I don't like my view because it's kind of small. So I'm going to try and change my view a little bit, just because I want to get closer, and that helps me out a lot. So for my x-axis, I'm going to start with, like, I don't know, -3. My y-axis as well, to start with -3. And then x-axis, I don't want to go that far. I just want to know what's going on over here. So I want to just go up to 5. But for my y-axis, wait, instead of 5, let me just change that to 10. So the whole point is you can do whatever you want, okay? And then the y value, I'm just gonna leave it the same. Okay, so now you have a little bit of a clearer picture, although they still look like straight lines. So what I'm doing is I'm just zooming out so you can see. If you look at the big picture, the blue one is what? It's an exponential function. And what is the orange one? It just looks like a straight line. Because the points we plotted are a little portion of the actual equation, it doesn't even really look like that. Because look, you go really, really close, and what does it look like? Like I said, they just look like two straight lines, okay? But they're not it, okay? So don't fall for the little tricks that your mind plays on you. And yeah, so let's get the equation. Y is equal to, so we're trying to match the blue one, right? A is 10,000, it says. We should already know, right? Because that's the original value. And then B is 1.05. We already knew this, remember? Because we were multiplying by 1.05 every single time, raised to the power of x. And yes, it's a perfect match. So what did we just do? We came up with the two equations, okay? So this is exactly what I want you to do. And so now let's go back, and we have to answer it, right? Not that one. Okay, there you go. So then the equation for f of x, was equal to 600x plus 10,000. And then the equation for g of x with the compound interest, I'm going to have to erase this part, was what? G of x equals the initial value 10,000 times 1.05 raised to the x power. Okay, so we answered number 3. Number 5, we're going to say after 3 years, the simple interest account is the better choice. Because you can have a balance of 11,800 with the simple interest versus right here $11,576.25 with the compound interest account. The reason why I'm writing this out for you is because I expect this from you. Okay, and then of course question number 4, we have already answered it as we were graphing it. It's either f of x or g of x a linear function, an exponential function. How can you tell? So yes, what did we talk about? F of x. So you're going to say f of x is a linear function. Well, how can you tell? Because we are adding by the same number every time. Okay? And then you can of course also say g of x is an exponential function because we're multiplying by 1.05 every time to get to the next number. Okay? Alright, so then now we are almost done. Okay, we just have to answer number 6, 7, and 8. Okay, so let's go back to the calculator. And when you go back to the calculator, you have to find the points where the two graphs meet, right? So let's do it. So one time they meet over here because both balances start off at $10,000, okay? After 0 years, that's when you put in the money right away. The next time when they meet is right here. I mean, you can try and put points anywhere, but it won't give you anything because it just doesn't. Why is it giving 3 years over here? I don't know, but okay, over here, when you click on that, it would tell you at 8.2 years, both accounts is going to be at $14,923. Let me see if I could zoom out and see if I could click on any other points to see if there's meeting anywhere else. No, but they're not. Okay, so there you go. At 8.2 years, both accounts will end up being at $14,923. But as you can see now, after that, the green equation, which is the compound equation, it would give you a higher balance than if you were over here with the simple interest account. And you can see that by just looking at the numbers. Okay, so then of course, what are you going to say? You have to go ahead and take a screenshot of all of this. Make sure all of that part shows up. I want to know that you give directions to the calculator for the first one for the linear equation, and for the second one an exponential function, and then you match the equation because that's going to show me how you got the equation. And I want you to go ahead and plot these 2 points to show me that you know that in 8.2 years both accounts would have the same balance, but after that you would be actually earning more money if you put your money in a compound interest account, right? And so take a screenshot and then you're going to have to insert it because I told you this is an open-ended question. And because this one question asks so many different things, I told you it's going to be worth 50% of your test, okay? So even if you know how to do just a few things, let's say you only did like one equation and you only have one line in here. That's okay. Whatever you have, just take a screenshot and, put it in there. Because if you did something, you get partial credit. But if you did nothing, you get zero. And that's a lot of points you're going to be missing. So now let's go back because we have to answer the rest of the questions. There you go. And right now, I'm just gonna erase all of this because it's just too many words. Okay. So at year 3, it was still much better to go with the other choice, right? So let's see. Number 6, find the values of your deposit after 20 years. Oh, I didn't do that, but we'll go into it in a bit. And it says use a graphing calculator to determine the length of time an account must be held for the two choices to be equally attractive. We did that, didn't we? We had to go back, and it was actually at 8.2 years, right? So, and it was already rounded. So it's going to be, it will take 8.2 years for both accounts. To give me the same amount of money. What should I say? This is difficult. I'm a math teacher. Okay. To have that, let's just say same value. Okay, there you go. And then you have to advise your investor down here, and that's the part I like. But over here, let's just solve this. What's going to be the value after 20 years? We have to go back. So to find that, I wonder if they could just, if I put in 20, would they give me an answer? No. I was hoping it would based on this. But anyway, what you have to do is you just have to plug it in, okay? So don't do this. This is after you take the screenshot. But before you take the screenshot, what you can do is if you want to find the answer, just instead of X, plug in the 20. And then it will give you the answer, which is 22,000, right? And that is in the simple interest account. And then over here, I'm going to put 20 instead of the X. And that's going to give you the answer for the compound interest account, right? $26,532.98. We have to round it. Okay? So, don't forget, you can only do that after you do the screenshot, okay? So, let's go ahead and finish answering. Find the value of your deposit. So, f of 20, that's the simple interest account because that's f of x, is equal to 22,000. And then g of x, that's the compound interest, that's going to be $26,532.98. Okay, so then you're going to say the compound interest account is a better choice after 20 years, obviously, right? And then now let's go ahead and answer our final question, number 8. Okay, so to answer number 8 is very simple. It says use your answer to problem 7 to write a statement that advises your investor. So this is the most important answer that you have to give me. Okay, so let me just write down over here, number 8. You should invest your money in a compound interest account if you're going to keep the money in the account for more than 8.2 years. But if not, it's better to keep your money in the simple interest account. And so that's it. Wow, it was really massive. But you see how one question can actually answer 1, 2, 3, 4, 5, 6 questions? That's why this is going to be 50% of your test. And so as of this, I am done helping you, letting you know what you're supposed to know. Okay, so there you go. I just want to give you some other pointers on what's going to be on the test. Okay? And so some of the other things that you have to know will be, how do you find the recursive formula? Okay, of a sequence. Another one would be, can you give me the end behavior? Can you give me the end behavior? And describe the transformation. This is kind of like I give you two equations. Y is equal to 3 raised to the x power. Y is equal to 3 raised to the x power plus 4. Then you got to tell me, oh, the graph went up by 4. That's the transformation. And then the end behavior is, if you graph it, it looks like this, right? So you have to say as x goes into infinity, y goes into infinity. As x goes into negative infinity, y goes into 0. So this is would be a good example. And that's probably it. Another thing, maybe you have to know the difference between linear and exponential. So this is really important that you know, because over here, understand linear, you add by the same number, and then over here, you're multiplying by the same number. Okay, and a linear equation looks like y is equal to mx plus b, and an exponential function looks like y equals a raised to the a times b raised to the x power, in parentheses that is. Okay, so and a linear equation looks like a line like this. Exponential looks like that, like this curve right here. And exponential functions grow at a faster rate. And so these are the only things you have to know. As you can see, I'm not giving you step by step and simple questions for every single one of them, just a few. I promise you that the test items will be no more than 10 questions, okay? All of them will be multiple choice except for that one question that I showed you how to do using the Desmos calculator and getting the equation and all that stuff. Happy learning. Goodbye.